You all. I welcome you all to the Rankplus JEE English. I hope you are fine. And in today's class, we are going to start and complete our very important chapter, work, energy, and power. I always tell to my student that there are only four things which we have to do in physics. The first is the force, calculation of force. You will see in multiple chapters you have to calculate force. The second one is the energy, third one is the work, and the fourth one is the power. Few physics is total physics, the acronym which I generally told in my class. So in today's class, we are going to go for these many topics. But before we start, please subscribe or follow our Telegram channel if you haven't, because on this Telegram group you will be getting the DPPs of physics. You will be getting the notes which I'll be doing here, and also there are so many things which you will be getting on Telegram, because I'm going to share each and everything whatever being useful for you on our Telegram channel. Okay guys, now let me start here as well, because you're coming from there. I have to zoom again and again. Yes, I'll be covering these many topics. So this is basically a syllabus from JEE Main 2025, and we have 8 topics, and the 9th topic is my approach, which I am going to use, at how you're going to tackle the questions from work, energy, and power. If you ask me that, sir, which is the basic topic or the basic chapter from class 11th, which is very important to study class 12th physics, this is the chapter name which I'll tell you: work, energy, and power. Because you will see that in multiple questions you have to apply the approach from this chapter. So this chapter is not only important for the concept which we will be covering, but it is also important for the approach. So here my main focus is for the approach, that what we are going to do. So the 9th syllabus part, which is not there in your JEE, is my approach to tackle each and every question here. So I have divided your syllabus into multiple parts, because why I'm doing this, you know what, syllabus is limited, approaches are limited, but the questions could be unlimited. So you must be well versed with all these concepts, and I'll give you the approach which will help you to solve any type of questions which might come from these topics. So let me start with the very first topic. Are you all ready? Please light up and mark your attendance in the chat. So let's start. The first topic first. What is work? So hello Ashwin, Harshan, Nirmal Rana. Class duration, we will be covering the JEE PYQs as well. So class duration might be around 2 to 3 hours. That will depends on your level. Shall we start now? So now, the first thing what we need to understand is work. I'll not take much time, because as this is a crash course, this is type of a one shot video which I have to put you. I want each and every points to be concise, and after watching this video you might be able to solve any questions that what I felt. So in this, it's not similar to the work which we study in the English language or any other language. Work in physics is basically a dot product between force and displacement. Force and displacement. Mathematically, you could write this as work is equals to F dot S. And if you know, I could write this thing to two format. First one is work is equals to, I will be taking the force component towards the displacement, F cos theta S, or it might be that you are considering the displacement component towards the force. What's the basic difference? Let's see. Assume that we are having a surface. On this surface, I have put one block here. The block mass is m, and I am putting a force here. I am pulling this object by a force F. and the angle is theta, the displacement will be in this direction. Now, when you see this situation, you are seeing that force and displacement directions are different, right? Force is acting horizontally, and this force is not in line with the displacement. Displacement is horizontal, and force is at a particular angle. So what we have to do, first thing first, we have to like make the directions similar. So I need to resolve this force in the same direction as of the displacement. I can do two different things. The first one is I'll take force direction in the direction of displacement. Then I could write here F cos theta. But what if I take displacement component towards the force? I will write S cos theta. So this is what I'm writing here. You can do two things. Either you have to take the component of force in the direction of displacement, this is F cos theta, or you have to take the component of S in the direction of F. The most important point is that the displacement and the force always to be in the same direction when we are calculating the work. Okay, so this is basically a first kind of pattern which we have to understand. Okay, and now if I'll not be going into this scenario, I could write this thing as F S cos theta. And here I can tell you that these work basically depends upon three different things: force, displacement, and the angle between the force and displacement. Right? So if somebody asks you that when could be the work done by any force will be zero. So you have three different situations. Let me write one special case here. Special case for work to be zero, work done for any force to be zero. There are scenario or conditions. Condition 1, either force can be zero or displacement can be zero, or you could say the cos theta will be zero, or you can say the angle, force and displacement are perpendicular. Force and displacement are perpendicular. And when force and displacement are perpendicular, the theta between them is 90 degree. These are the three things, three scenarios in which we can say that the work is zero. There are few examples which might come in your exam. Assume that there is a surface and one person is moving with a tray in his hand and there is some weight on it. You know what? The gravitation will always act downward. So I am telling you that the gravitational force which is acting on this mass will be equals to the weight, and weight will be equals to mg. And this person is moving in the forward direction. The horizontal direction. The displacement is in this direction. The weight acting on the body is downward. And you know what? There will be an angle of 90 degree between them. And if somebody asks you that what will be the work done if this person is moving in a horizontal plane, or a porter is moving on a horizontal plane, then the work done will be zero. And work done will also be zero if there is a nucleus, and around nucleus if electron is moving. Okay, because there will be a force of attraction and the displacement, there will be an angle of 90 degree. So these are some special cases where you will find that the work done is zero. And now I'll go with the pattern of questions which might come in your exam. I hope that this thing is clear to you. Now, is this thing clear? Nirmal, Ashwin, sir, I'm new to the channel. Will I able to if I watch from today your crash course, will I able to get 99 percentile? For getting the 99 percentile, Ashwin, what you need to do is just watching these lectures won't be enough. You have to solve the DPPs as well, and you have to solve at least 5 years PYQs. I have to be blunt for this thing, right? After watching this video, you have to solve questions. But I can assure you that after watching this video, you will be able to solve every questions, right? It might take time. Why I'm telling you that you have to do the practice, because your speed is very, very important. It will happen that you can able to solve the questions, but if you haven't done your practice, then what might happen that you will be taking more time, and JEE won't be giving you extra time, right? If you are not from a particular category. Second attempt. Yes. Now let's move. I'm a kind of a teacher who believes in that there are patterns in physics, and these patterns repeat. And if you know these patterns, you will score more, your speed will increase, and everything you feel like this is coming again and again, right? So, because these patterns are very, very important, and I watched one video of H.C. Verma sir. If you know, there is a very popular book for JEE aspirants, H.C. Verma book. So H.C. Verma was a professor at IIT Kanpur. I was watching one video of him. He told that it's an illegal method which generally coaching teachers uses to teach JEE aspirants. They teach the patterns of questions which might come in the exams, and due to that, what happens that student won't be applying his or her brain, and he would be able to solve questions in a few seconds. So this method is illegal if you consider this, but this method is very, very important to get the correct correct approach, I would say, or to solve each and every questions in few seconds. So the pattern of the first thing, calculation of work, you might be getting when force is constant. When force is constant, it could be a vector format, or it could be a scalar format. First, I'll make a mind map for this pattern, and after that we will solve previous year questions, and you will see that from this pattern only the questions are coming. I have already taken the questions from JEE 2024 mains, 2023 mains, so you do not have to worry about those things. Okay, so calculation of work you will be getting when the force is constant. There could be a scenario when it is being given in a vector format or in a scalar format. If the question is in a vector format, then force will be given in a vector form. So I could write this force as x I cap plus y j cap plus z k cap, and there will be displacement also. I can write the displacement as a I cap plus b j cap plus c k cap. And if somebody asks me that what is the work done here, so work done is basically a dot product of F and S, right? So I have right here the force in a vector format, the displacement in a vector format, and you know that in a vector format, basically what we do is, if anything is going towards the x-axis, I'll keep an I cap here to point out that this object is going in the x direction, and if the object is going in y direction, I'll keep k cap here. If this is going in the z direction, I'll use k cap as the direction, right? So here what I have to do is I have to do the dot product, and for the dot product you do not have to take any tension, because in dot product we know that we just have to multiply the I cap with I cap, and we do not need to worry about the other formats, right? So I could easily write it's ax plus by plus cz. Okay, so work done, and work done is a scalar quantity, so you won't be getting any I cap, J cap, or K cap here. If this is in a scalar format, then kindly note one thing: direction of force or component of force direction of force or component of force and displacement or component of displacement must be same. Must be same. Okay. Now here you have to just multiply Fs cos theta, right? So this is one thing. Another thing, when you are getting force as a variable, so if force is a variable quantity, you could do one thing. You have to integrate force dot displacement. You can take the positions as initial and final. So this is the formula which we are going to use. So for the variable forces, we have to integrate. For a constant forces, we just need to do the dot product. And there is another case, if we being provided by a graph, and if we have been provided by a graph, what we need to do is we just need to find out the area between the force and the displacement graph. This area under curve will give you the work. This area under work, the area under curve will give you work. Work is equals to area under fx curve. Okay, so this is basically a format or a pattern for the calculation of work. Now, can we move forward? Is this thing clear? Even if this thing is not clear, do not take tension, because we are going to solve multiple questions related to this thing. But why I'm writing this thing first? Because if you are revising, then you know what? For revision, your revision must be fast. For a student whose revision is fast, the chances of getting selected is very high. And once you know that this is only the pattern which might come in your exam, and you know that what type of questions is there, easily you can score very well. So, so where to get a test in the order of chapters you are teaching? I'll teach you. Like I'll share that thing. Do not take tension, Ashwin. Just be completely focused here when you are here. So see, there is a one question. A block of mass 5 kg slides down an incline of inclination 30 degrees. So I'll draw one diagram for you. The mass is 5 kg. The angle here is 30 degree. Okay. Now the length which is provided to you is 10 meter. And you know what? Basically, work done is always tagged by the type of force. Work done is always being tagged by the type of force. So here in this question, they are asking you the work done due to the force of gravity. So you know what? The gravity will always act downward. Gravity will always act downward, and here you could write that weight is equals to mg, and I'm taking the value of g as 10. So I could write this as 5 into 10, 50 Newton. 50 Newton is the force of gravity which is acting on this block. And I already told you that here this note tells you that the direction of force and the displacement must be in the same direction of force, and the direction of the displacement component must be in the same direction. So here the force is acting downward, and I could do one thing. I have to take the displacement also in this direction. Even though I know that this object is moving in the inclined pattern, right? Like this object is going in this way, but I have to take the displacement in the same direction as that of the force in which it's acting. So I could write this displacement as you can take one thing, this triangle, and apply the trigonometry. So you will be getting this L sine 30 degree, right? So this is basically the displacement. So I could write force is equals to 50 into length is 10, sine 30 degree is 1 by 2. So your answer will be 250 joule work. Basically, we are finding the work here. So your work done will be equals to 250 joules. So this is the method number 1. This is the method number 1 which I am using here. Here what I do is I'm taking the force as mg, and I'm considering the displacement in the direction of the force, so that the force and displacements are acting in the same direction. Now here some of you might get doubt, sir, why you are using the sine 30 degree here? We have studied the formula. You told us that the force, displacement and the cos theta will be there, but sir, why you are using the sine theta here? Because I told you that when you are calculating the work, you have to, the first thing which you have to keep in your mind is that the force direction and the displacement or the component of displacement direction must be same, right? This is what I am doing here. Is this thing clear? Or for the method 2, what I have to do is, the displacement is happening in this direction, so I could do one thing. I have to change the force direction. Let me draw another diagram for you. Let's say this is 5 kg mass, and on this 5 kg mass the gravitational force is acting downward, and this is 50 Newton. Okay, you know what? The displacement is happening in this direction, and the displacement is given to you as 10 meter. This angle is 30 degree, but if this angle is 30 degree, then this angle is 60 degree. So I could do one thing. I can take the component of this weight in this direction. So if I'll take the component of this force, this weight in this direction, I have to write weight as cos 60 degree, right? And my work done, consider this as force, because W will confuse you with the, so work done will be equals to F cos 60 degree into displacement. So I could write this thing as 50 cos 60 degree is 1 by 2, displacement is 10. My answer will be 250 joules. So this is method 2. Here I had taken the component of displacement in the direction of force. Here, I had taken the component of force in the direction of displacement. So these are two methods which you have to use, and you have to keep these methods in your mind. Is this thing clear? Nirmal, Ashwin, please do let me know, yaar, guys. You know that there is a rule when you are attending the online class, and when you are attending a kind of a teacher's class who is very active in looking for the chats. You have to like write after every 1 minute or 2 minutes. You have to write something. Yes, sir, I got it. I got it. Eureka, eureka. You can write eureka, eureka for a physics person. Is this thing clear? Nirmal Ram. And please do let me know that where are you from. So let's move. Now, this is a question. Again, this question is from JEE 2024, April attempt, 5th April shift 1. This was the question. According to the question, a body of mass 50 kg is lifted to a height of 20 meter from the ground by two different ways. Okay, there are two different ways by which we are basically lifting this object to a height of 20 meter. So these are two methods. First one, we are having a mass of 50 kg and we are lifting it using the lift, and we put this object here. Okay, the height we have raised is 20 meter. And again, we have raised 20 meter height, but this time now a person is taking this object to this side, and the angle of inclination is 30 degree. Here also the angle of inclination is 30 degree. In the case 1, we have pulled it straight up. In the case 2, along the ramp, we are taking the object. Okay, now you have to find out the ratio of the work done against the gravity. Again, I already told you that work done is always being tagged by the type of force we have to calculate. So here also the work done we have to calculate against the gravity. For both the cases, you have to find out that what will be the answer. Please do let me know in the chat. What will be your answer? What will be your answer? The first case, we are moving in this direction, and then for the second case, we are moving in this direction. Please do let me know. And if you have studied this chapter earlier, and so I can say that within few seconds, you could mark the correct answers according to the options. Please do let me know. Tamil Nadu. Okay. And have you watched Pushpa 1 again? To watch Pushpa 2? Please do let me know this thing also. Have you watched Pushpa 1 again to watch Pushpa 2? Of course, I think. You know what? We always try to watch sequel. That like whenever there is a sequel movie, before watching the next part, we always want to see the previous part, isn't it? But when we are going for the exam, we thought that just by studying for the once or for 2 times, we could able to clear the exam. It won't happen that way. You have to do multiple revision for the same type of concept which you have studied, because you know that revision is basically a bridge from learning to the mastery, and you have to follow that thing. No. Okay. And please do share this session with your friend. So here, our answer will be 1:1. Our answer will be 1:1 because work done does not depends upon path. Work done due to gravitational force. Work done due to gravitational force is independent of path. Even if you calculate, see, this is my basic questions which I teach to every student in my class. This is the question which is there in your JEE exam. So you could find out that whatever I'm going to teach you, you'll be getting similar type of questions in your exam. So here, work done due to gravitational force is basically independent of path. That's why I could say that the ratio which is being asked in the question is 1:1. And if you are going to calculate, you can easily do the calculation. For here, the work done will be equals to mg into h, and for here you can take again this side force, you can take due to gravity, this, right? Let's move. Now again, there is another standard question which I'm going to teach you. According to this question, a block of mass m is pulled along a horizontal surface by applying a force at an angle alpha with the horizontal. The frictional coefficient between the blocks and the surface is mu. If the block travels at a uniform velocity, find the work done by this applied force during a displacement d. If the block is traveling at a uniform velocity, what does it mean? It means that there is no acceleration at all, right? So let's take there is one surface. We have a block of mass m. We are applying a force at an angle of alpha. Okay. Now I can do one thing. I can resolve this force into its component. So I have to take f cos theta in this direction, f sin theta in this direction, and displacement is given to us t. So displacement I am taking in this direction. There is a friction between the block and the surface. So friction will act in the opposite direction, because if I'm moving this object in this direction, the friction will act at here. There will be a weight mg, right? And there will be a normal force here. So you can do one thing. If they have asked you that find the work done by the applied force during the displacement, so you could write that work done will be equals to f cos theta d. This is our first equation. Very simple. But we have to do multiple things here. So if I consider the horizontal forces, because these forces will be balanced, right? If I'll consider the horizontal forces, these forces must be balanced. Are you all agreeing? So I could write one thing. For the horizontal forces, I could write that f cos theta is equals to frictional force. F cos theta will be equals to frictional force because there is no acceleration at all. So if acceleration is 0, since acceleration is 0, I could say that summation of fx will be 0. Since there is no acceleration in the x direction. Now, if I'll see the vertical forces, so to balance the vertical forces, I could write f sin theta plus n is equals to mg, and frictional force is equals to mu n. Okay, find the n here. N will be equals to mg minus of f cos theta, f sin theta. Put this value here. We'll get f cos theta is equals to mu times of mg minus f sin theta. Are you all agreeing? Is this thing clear? Now, array, let me know. Is this thing clear? Hari? Any trick or direct formula? Yes, there are tricks and formulas, but first you have to understand that how to get the correct approach. Because if your approach is not clear, then you'll face issues in every question, right? So your approach must be very clear. This is what I'm going to teach you. Shall we move? Shall we move? Right? So you can do one thing to find f here. I can solve it further. F cos theta is equals to mu mg minus of mu f sin theta. You could find f here as cos theta plus mu sin theta is equals to mu mg, right? And you can find out a force F from here. So your force will be equals to mu mg divided by cos theta plus mu sin theta. And you can put it here according to equation number 1. According to equation number 1, work done is equals to F cos theta dot d. Right? So I can write, I'll consider this as my work, this as my force, mu mg cos theta d divided by cos theta plus mu sin theta. So this will be my work done. Okay. I hope that this thing is clear. Shall we move? Okay. Now, again, there is a question from JEE Main 2023, first Feb, shift 1. Here in this question, a small particle moves from this to this. No. Move to. That means this is the final position. From its initial position, this is the initial position. Under the action of a force. So we have been provided with the force, initial value of the displacement locations, and we have to find out the work done. So you know what? Work done is equals to force dot displacement. So first thing you have to find out the displacement vector. So displacement vector is final minus initial, 5 minus of 2i, 3i cap, minus of 2 minus of 3 minus of 5j cap, k and this plus k minus plus 5k cap. Is this thing clear? So this is our displacement vector. So you can write 5i cap plus 2j cap plus 7k cap now. Dot product is the simplest product. You only have to multiply I cap with I cap, J cap with J cap, K cap with K cap. Okay. So I can write work done equals to 5 3 15 minus 10 plus 35 40. 40 joule we are getting our answer. And this question comes in numerical format. You know what? When we are solving the numerical type questions, there is a doubt in our mind that whether we got the correct answer or not. These are the types of questions in which you can 100% sure that whatever you have done is correct. So you can easily mark that the answer here will be 40 joules. You have to fill this in your answer sheet. Nirmal Ram. Nirmal Ram from Tamil Nadu. Is this thing clear? TN? Right. Another question. This question is from JEE Main 2023, first Feb shift 2. This question was in first shift and this question was in second shift. Similar type of question it is. According to this question, there is a force. This is a variable force which is being provided here. 5 plus 3y square. In the y direction it's acting. You have to find out the work done by the force when there is a displacement from 2 meter to 5 meter. So I already told you that for a kind of these variable type of forces, we have to integrate, right? From where to where? From the initial position 2 meter to the final position 5 meter. We have 5 plus 3y square dot dy. So work done will be equals to 5y 3y cube by 3 y cube 5 2. Work done is equals to 5 minus of 2 plus this. So work done 5 3 15 plus 5 has a 25. 25 into 5 125. 125 minus of 8. One one seven plus 15. 232 joules. Are you getting this? Please let me know. 132. Yes. 132. Are you getting 132? Are you all getting 132 joules as your answer? Nirmal Ram, have you got the correct answer? Have you got the correct answer? This question is from JEE PYQ. There are still few students who believe that watching the motivational videos will motivate them to score very well in your JEE exam and this exam, JEE 2025 January attempt. But this won't be going to happen. You know what? You can get the confidence only when you are solving the question and when you matches the answer, your confidence increases, right? This is the best motivational dose which you can give to yourself, that whenever you are solving the unsolved puzzle, unsolved questions, and the moment you see the answer matches with the solutions what you were doing, your confidence will rises, right? So this is what we are going here. If you got this correct answer, then think of like an IITian. Here, the question from JEE Main 2023, 11th April shift 1. According to the question, we have been provided with the force similar to the kind of a force which were there in the previous type. So in this question, I already told you that in if you are solving the previous year question, the questions are not important for us. What is important for us is the pattern. And I already told you that which type of questions might be coming in your exam, and we are solving the previous year questions here, right? So here the force is provided to us is 2 plus 3x. Okay, this force is in the x direction. This force is in x direction, and the displacement is happening from 0 to 4. So for getting the work, we can integrate it from 0 to 4. 2 plus 3x dot dx. Integration is very easy. You just need to increase the power. So if you increase the power, it will become 2x plus 3x squared divided by 2. You have to put 4 and 0, and it's still very easy when you are having one initial value as 0, because you do not have to solve it for 0, just you need to put the value 4 here. So you'll be getting 8 plus 4, 3 into 4, 4 is 16 divided by 2, 8. 8 0 24. 24 plus 8, your answer will be 32 joules. Are you getting 32 joules here? Please do let me know. No, sir, I make mistake. Okay, no issues. There could be some mistakes when you are solving. Shall we begin now? Now, before moving forward, let's have some more concepts. Now assume that I'm having a pendulum of mass m, the length L, and if I raise this pendulum, by an angle theta. Okay, and you have to find out that what is the work done to move this object from A point to B point. Find the work done to move a pendulum to move from A to B due to gravity. Similarly, this type of questions, the same type might also be there. This type of question. There is a hemispherical bowl. There is a ball of mass m. The radius is L here. And you have raised this to an angle theta. Okay. And you have to find out that when this object is being moved from A to B, when this object is being moved from A to B, what will be the value of work done? And to calculate this work done, what are your basic steps? We know that when we have to calculate the work done due to gravity, there is a very simple formula that force and the displacement must be in the same direction, right? So I could write that work done is equals to force of gravity into displacement due to gravity. Force due to gravity and displacement against gravity So force due to gravity is mg, which is acting here. And I have to find out that this is the displacement, because if this object is being raised by a height h, or you can say displacement, I'm taking this as s, then what will be my work done? To get this s, you have to do one thing. As we know that this distance is L, this is L, this is L cos theta. Okay, so my S will be L minus of L cos theta, and you could write this as L 1 minus of cos theta. So I can write this work will be equals to mg L 1 minus cos theta. This is very popular formula. This is very popular formula, and you might, if you are solving the previous year questions, you will get this type of question. This question was correct? Okay. I hope that this thing is clear to you. Right? Now, let's move. You know what? The chapter name is Work, Energy and Power. The chapter name is Work, Energy and Power. And whenever we are studying any topic, generally in physics, we used to see the topics or the terms in terms of the unit which they have, in terms of the dimensions which they have, right? So if I'll talk about the work, what is the SI unit of work? What is the SI unit of work? The SI unit of work is joule. And if I'll talk about the energy, the SI unit of energy is also joule. The dimensions will also be the same. Dimensions similarly. Okay. So now, when units are same, dimensions are same, could you guess one thing? That there might be some relation between work and energy. There is 100%. There is a relationship between work and energy. Work and energy are like, you can say, a bonded things. We cannot separate work from energy, and there might be some situations in which somebody is asking you that you have to calculate the work, but you are not able to calculate the work according to the concept or the patterns which I told you. I told you that you will be getting the work only in these three patterns. Either the work, you have to calculate the work done due to the force when the force is constant. You have to calculate the work done due to the force when the force is variable. Then you have to take the integration, or you might be provided with a graph of force versus displacement, and you have to calculate the work done. Right? These are the scenarios according to which we can proceed. But there are some situations in which the questions might be asking you that calculate the work, but you are not able to get the work according to the formula which we have studied. And in those types of questions, what you have to do is you have to think, you have to again think in terms of energy. If you started to think in terms of energy, you can solve that questions within few seconds. You won't be taking much time, because I am here to tell you, to give you the approach which you could use while solving the numericals, and to solve numericals fast. Right? I'm here to transform your way of calculation. I'm here to transform your way of thinking, your way of approach solving the numericals. Because I believe that if I'll change the approach, then you will remember me forever, right? You will remember me that there was a teacher who taught me these kinds of methods, and you will use those methods in your life as well, because we get to see that how we are going to observe anything. Here I am observing that the work and energy are interrelated. There must be some bridge. There must be some bridge which will connect work with the energy, and the bridge that connects the work with energy is work energy theorem. We have work energy theorem. What does this work energy theorem say? It says that work done is equals to change in kinetic energy. Work done is equals to change in kinetic energy. And for a conservative forces, you could write this minus of delta P. This thing you have to keep in your mind. And finding out the kinetic energy and potential energy is very, very easy. Kinetic energy formula is very, very easy. No matter which topic you are studying in physics, the formula remains the same. But potential energy is very, very difficult. Every time the topic changes, the potential energy formula gets changed. So here, the value of kinetic energy is equals to half mv square, right? I'm not going into the derivation part. So the kinetic energy formula is half mv square, and you have to remember kinetic energy formula in terms of the momentum. If I'll multiply this number by m and m, I'll get my answer, this mv square divided by 2m, and you could write this kinetic energy as p square divided by 2m. Okay, this p square divided by 2m. So this is one of the formula. This is another formula. And if there is a rotational kind of situation out there, rotational kinetic energy, you could use half. Moment of inertia will replace my mass. Angular velocity will replace my velocity, but the formula pattern will remain same. I hope this thing is clear. For the potential energy, you could think of, for the potential energy, you could think of in terms of gravitational force, there is a different form. In terms of magnetic potential energy, there will be different form. Like when the force gets changed, the potential energy formula gets changed. So we will use those formulas according to the situations in which we got the question, right? Now let's move and solve the question. I hope that this thing is clear to you. Energy is basically the amount of work done which you can do. Let's move forward. Now, this question is from JEE Main 2023, 24th Gen Shift 1. Try to solve these questions on your own, and do let me know that if you are facing any issues. In this question, a spherical mass of 2 kg starting from rest. See, whenever you are reading the question, a smart kid, usually what they do is they transform the question into the data. So here, if I'm reading this question, according to this question, this object is starting from rest. I'll keep one thing in my mind, that the initial velocity is 0. Acquires a kinetic energy of 10,000 joules at the 5th second. That means duration of 5th second is given to us. Time is 5 seconds. The force acting on the body, they are asking. So in this question, you have been asked force, and you know what force is equals to mass into acceleration. Mass is already given to you as 2. Acceleration you do not know, so you know that just you need to find out the acceleration. So how you could get the acceleration? Kinetic energy is given to you as 10,000 joules, and you could write this thing as half mv square. 20,000 divided by mass. Mass is 2. Or I do one thing. I'll put 1, 2, 3, 4. Half into 2. V square. 2, 2 will cut. V will be equals to 100 meter per second. U is 0 meter per second. Time is 5 seconds. So according to these three different data which I got from the question, can you use equations of motion to get the acceleration? We know that using the equation of motion, I could easily get velocity is equals to 80 and acceleration will be 100 divided by 5. Acceleration will be 20. Can you? And if acceleration is 20, force will be equals to 2 into 20. Force will be equals to 40 Newton. So 40 Newton will be my answer. And this question was asked in numerical type pattern. Are you observing one thing? That in 2023, most of the questions which you got from this chapter, work, energy and power, were questions in the numerical type pattern. So you won't be getting the options here. I have seen multiple students solving MCQs and getting the shortcut tricks to get the answer. But wherever, or I would say in few topics in which we have the shortcuts, which is a genuine shortcuts, which you can use to get the correct answer out of the options, will fail when you are getting the questions in numerical type pattern. So please avoid those shortcut tricks. Try to get the things correct. Try to get familiar with the concepts. Try to get familiar with the approach which we have to use again and again. Right? Now, shall we move forward? Nirmal Rana, was it correct? Ashwin, Nirmal Rana. Shall we move? Let's move. Here, another question from JEE Main 2023. 24th Jan shift 2. A body of mass 1 kg begins to move under the a body of mass 1 kg begin to move under the action of a time dependent force. So force is provided to us. T I cap 3t square j cap, where I cap and j cap are the unit vectors along x and y axis. The power developed by above force at the time t 2 second will be. So here we have to find out the power. You know what does power means? Power is basically work done divided by time. It tells us that how fast you can do one work, or you could say that power is equals to energy divided by time. The rate of energy, the rate of work done. And power is equals to, if power is equals to work done by time, I could write this as force into displacement divided by time. Displacement divided by time, you could write this thing as force into velocity. So please remember this formula as well, that power is equals to force into velocity. Because I have seen that in few recent years of exams, you got direct question using this formula, that power is equals to force into velocity. Let's solve this question. Here you have to find out the power developed by the force at the time t is equals to 2 seconds. Okay, force is provided to you. You have to calculate the power, and we know that power is basically is equals to force into velocity. But the issue is that we do not know about anything. What is the velocity vector here. So how could we get the velocity vector? So for getting the velocity vector, I could use one thing, that force is equals to mass into acceleration, and mass is equals to dv by dt. So my force is T plus T I cap plus 3t square is equals to mass is 1 kg dv by dt. So from here, if you calculate V, you will get T square divided by 2 I cap plus T cube J cap. Okay. And now you can replace here. You tell me that force and velocity, will it be a vector product or scalar product? Power is a scalar quantity, right? So we have to do the dot product here. You could write T I cap plus 3t square, T square divided by 2 I cap plus T cube J cap T cube divided by 2 3t5. Okay. Now put the value of t as 2 seconds. Hundred watt. Are you getting 100 watt? Please do let me know. 100 watt is the answer here, and there are no options being provided. No options being provided. This question was asked in a numerical format. I hope that the approach is clear to you, that how we are going to solve this question. We know that power is equals to force and velocity. Velocity we do not know. So according to this force, what we do is, force is equals to mass into acceleration, and acceleration is basically the rate of change of velocity. So I integrate this terms to get the velocity vector, and when I got the velocity vector, I just like what we have to do is the dot product between the force and the velocity vector, and we got this thing. I hope that this pattern of question is very clear. Oh, very clear. Great. And all of these questions are basically the questions from JEE PYQs, right? There are two approaches which we generally use as a teacher. The first one approach is that when I'm teaching you the concept, I'll teach you the concept, I'll explain you each and everything, and we will do the numerical parts later on. And the another approach is that when we are like, I'll take a question, and in that question I'll be explaining you that why I had done this scenario and what is the concept required to get the correct answer, right? This is what I am using currently. I'm giving you the question and I'm telling you that this is the approach which what we have to use, and these are the concepts which you have to keep in your mind, right? Because this is the exam time and we hardly have 1 month left. And in this 1 month, why I'm telling 1 month, because I want you to have a time to have the time for the revision, because ultimately I have seen that result can only be produced when you are good at revision. The more you revise, the more confidence you will be getting, the more speed you will be getting. Even like you have watched this video, go and download the previous year questions 2023 2024, try to solve those questions on your own. Even if you have solve this question with me, you have to try and get the correct answer on your own. The moment you started getting the correct answer, your confidence will rise, and the moment your confidence will rise, you will start solving some questions which you haven't attempted earlier. This is the power of confidence, and this is what I want in you, right? Shall we move forward? Now, this question is from JEE Main 2023, 25th Jan Shift 1. This question seems to be very difficult. This question was asked in a numerical type, but if you start solving this question, or if you try to attempt this question is very easy. Till now, whatever we have studied, we will be able to solve this question. According to this question is asking you that the kinetic energy of the object will be this thing. And you know what? Whenever somebody is asking me the kinetic energy, the first thing which comes to my mind is that kinetic energy is very simple energy, and the formula is half mv square. But if I use this formula half mv square, I'm seeing that it won't give me the correct answer, right? Won't give me the correct answer. Even though I haven't studied the complete formula, my habit is to just see what is being asked in the question and then see that what are the options available there. You will see that using this technique, your speed will increase. So here what I am seeing that the question is asking me the kinetic energy, and this is being provided. The kinetic energy we have to write in this format, and if I am writing the kinetic energy in this format, I'll have to get the value of n. So seeing this thing, I can pretty much sure that I can't use kinetic energy formula half mv square. And I already told you that there is one approach which I'll be using whenever I'm getting the questions from work, energy and power chapter, that work and energy are interrelated and they have a very good bond between them. If the question is asking you the energy, and if you are not able to get the correct answer using the formula which you have studied, then the next moment you do not have to waste your time. The very next moment you have to start thinking in terms of the other thing. So in this question, we have to, if I'll started to think in terms of kinetic energy half mv square, I'm seeing that I will not be getting the answer which I want. So the very next moment I'll start thinking in terms of work. Are you getting my point? Are you getting my point? Please let me know. Are you getting my point? I hope that this point is clear. So now let's start. An object of mass m, this is the mass m here. Initially at rest, we do not have velocity, initial velocity here. On a very smooth surface, there is no friction at all, and we are providing a force of 2 Newton. In the process of its linear motion, the angle theta between the direction of force and the horizontal, okay, so you know there will be a component of force F cos theta here, and theta being provided to us as kx. Theta is being provided to us as kx. So I could write this thing as F cos kx. Okay. And x is the distance covered by the object from the initial position. Okay. So displacement is also given, that this is x. So I told you that very next moment what you have to do is you have to think in terms of work, and work is equals to F dot dx. Is it clear? Force is 2 Newton. 2 integration of cos kx dx, and work is equals to 2. The integration of cos kx will be sin kx divided by k. You got the answer. You got the answer. See how simple it is. How simple it is. You just need to remember that there is Manoj Sir approach. And I always says that there is my approach, Manoj Sir approach, MSA. There is Manoj Sir approach that if you have to calculate the anything that here I have to calculate the energy, and the very next moment I got into my mind that the kinetic energy formula is half mv square. I'm not able to use that formula in this question according to the variables which is being provided. So I started thinking in terms of work, and when we have to calculate the work and I'm not able to get the work value using the patterns which I told you, uh, these are the patterns. I'm a kind of a teacher who will teach you in patterns, and those patterns will get repeated in your exams, and you will be happy to see that fortunately it's being your fortune or it's being your luck that you got this video there and you have spent so much time to watch this complete video to get this chapter clear to you. So these are the patterns in which you could get the work numericals. Work you have to calculate when the force is constant, force is variable, and there is a graph, right? So now I hope this thing is clear, my dear. Please do let me know in the chat, and do share this session with your friends. I get the same. Really very simple, right? Now let's move. Let's move. This is our next question. A 0.4 kg mass takes 8 seconds to reach the ground when dropped from a certain height P above the surface. This question is from 2023, 29 Jan shift 1. A 0.4 kg mass takes 8 seconds to reach ground when dropped from a height P above the surface of the earth. The loss of potential energy in the last second of fall. What could be? What could be? Height is P. And you are dropping something. When you are dropping something, it takes 8-second time. Okay. I can easily get the value of P here. How? We know that S is equals to ut plus at square. Acceleration is equals to g. 10 meter per second square I can take. So S is equals to half at square. P is equals to half into 10 into 8 into 8. 5, 8, 5, 40, 40 into 8, 8. 320 meter. Are you getting 320 meter? So height is not provided to us. We can easily get the height using this thing. If we are dropping something and we are getting the 8, it is taking 8 seconds fall on the ground, then it means that the height is 320 meter, right? Now you have to calculate the potential energy in the last second. You have to calculate potential energy in the last second. How we could find out potential energy, but due to what? Potential energy due to gravitational force, and we know that potential energy due to gravitational force is mgh. Mass is provided to us 0.04, and g is 10. Height we do not know. That means it's 4h. Okay, to calculate the value of h, I can use the Snth equation, which is u plus a by 2, 2n minus 1. Can I use that? Can I use that thing? Yes. And if I use that, so Snth will be equals to my h, and that is 0 plus 10 by 2, 16 minus of 1. Okay. 5 into 15. 75 meter. So your potential energy will be equals to 4 into 75. 75 into 4, 5 for the 20, 7 for the 28, 29, 300. So 300 joules will be your answer. Now do let me know, is this thing clear to you? Sir, why not S is equals to V square minus U square is equals to 2S? Or why not S is equals to UT plus half AT square? This is what we are using. S is equals to UT plus half AT square. See, S is equals to UT plus half AT square. But in this scenario, U is 0. If U is 0, then I could easily tell you that it's half AT square. Right? I think Sai Tharun, you haven't watched my kinematics lecture, because in kinematics lecture, I have discussed that how to use the equations of motion. And using the equation of motion is very, very simple. Just you have to understand that there are, in total, we have 5 variables. In total, we have 5 variables. The 5 variables are UV set: initial velocity, final velocity, displacement, acceleration, and time. Out of these 5 variables, you will always have 3 variables being provided to you. Because if you see that any equation of motion will comprise of 4 variables. And if every equation is having 4 variables, to use those equations, you must be provided with 3 equations, only one will be left. Right? Harun, Nirmal. So Sai Tharun, where are you from? And do like this session if you haven't. This is very, very important, very, very critical. Shall we? Shall we move? Shall we move? Now, here. This is basically a conceptual question from JEE Main 2023, 29th Jan Shift 2. According to this question, you have to find out that which of the following statement is correct. The first and foremost thing what you have to see whenever you are getting these types of questions, that whether the question is asking you the correct statement or the incorrect statement, right? So this question is asking us the correct statement. So if whenever I'm getting any incorrect statement, I'll also marking these options, right? I'll also be marking these options that this won't be my answer. So work done by a man in lifting a bucket out of a well by means of a rope tied to the bucket is negative. Actually, this question is from the NCERT. If you see the NCERT first question, back exercise, the same question, this question is basically inspired from that question. We know what? Work done could be positive. Work done could be positive. Work done could be negative. Work done could be 0. To get the work done, to get the positive work done, we know that the force and displacement must be in the same direction, or the force and displacement angle must be acute. Then we will get the work done as positive. To get the negative work done, we can say that the force and displacement will be in the opposite direction, or you could say that force and displacement are having an obtuse angle. Okay, then for a 0, the force and the displacement is perpendicular to each other. So these are the things which is there. Now, work done by a man. What is the force here? The force due to the men. Assuming that this is a well. Have you seen any well? Like, I haven't seen well near to my area. And even when we go to visit somewhere, then the well, whatever, whenever I found well, those wells are dry. There is no water at all. But still, in the questions, we are getting the questions like there is a well, and in that well, you are using a rope. And this person. So this person is applying in lifting a bucket out of a well by means of a rope tied to the bucket is negative. No, it's positive. So this statement is wrong. And if this statement is wrong, I can mark this question that it won't be my answer. Very next moment, work done by gravitation force in lifting the bucket out of a well by a rope to the bucket is negative. Yes, it's correct, because the force of gravity is acting downward and the displacement is happening in the topmost point, like it's going up. So this is correct. B will be the answer, and here I'm seeing that in every options I'm getting the B. So I have to check another options. Next, work done by friction on a body sliding down an inclined plane is positive. Work done by a friction. Can a work done by a friction be positive? It won't. Right? So this is also wrong. Work done by the applied force on a body moving on a rough horizontal plane with uniform velocity is 0. See? Work done by an applied force on a body moving on a rough horizontal surface with uniform velocity is 0. No, it won't be 0, because you are basically overcoming the friction, right? You have to consider that friction. So that won't be my answer. So I think that if C is not there, this is not there, then these won't be my answer. My answer will be this, B. Work done by air resistance on an oscillating pendulum is negative. Yes, this is correct. I hope that this question is clear. Arun, shall we move? Shall we move? Now, here, this question is from JEE 2024, 9th April shift 2. JEE 2024. We have been provided by a force, displaces a body from this to this. You have to calculate the work. And I already told you that there are only 3 patterns of work which could be asked in your exam. The first one is when the force is constant. The second one is when the force is variable. And the third one is that you will be being provided by a graph. Here, the force is variable, and when the force is variable, we have to do the integration f dot dx from 2 to 4. So it's 3x square plus 2x minus of 5 integration 2 to 4 dot 2x. You could do one thing, 3x cube divided by 3 plus x square minus of 5x, 4 and 2. Okay, now 4 4 64. Please do the calculation on your own, because it might be that basically I'm very close to the board. Now it might happen that I won't be able to see few values or something, some mistake could be there. So you have to do on your own, and please after that we will check that who got the correct answer. So who got the correct answer will get a reward. Reward from where? Reward from me. 64 minus 8, 56 plus 12, 58. 58 joules. Are you getting 58 joules? Are you getting 58 194? Nirmal, Sai Tarun is getting 54 58. I'm getting 58. Please do let me know. 194. Shall I need to check it again? I do not have the correct answers because I believe that these questions are very, very simple. 3x by 3. I think that this is the correct answer. I think that this is the correct answer. Are you getting this? Let's move. Now, this question is from JEE 2024, 29th Jan Shift 1. According to this question, a block of mass 100 kg slides over a distance of 10 meter on a horizontal surface if the coefficient of friction is being provided to you. So let me draw first. Let me explain you this concept first. There is a mass. Mass is 100 kg. Work done against friction. You have to calculate the work done against the friction. Okay. You are sliding this thing to a distance of 10 meter. Mass is already provided to you. What will be the force of friction? Force of friction will be mu n. 0.4 into normal force will be 1000. N will be mg. (400 Newton), right? And you need to calculate the work done due to friction. (4000 joules). We got this thing. Are you all getting 4000? Okay, let's move. This question is from 2024, 9th April Shift 1. I can see that now you can solve this question. This question is very, very easy. Sometimes it might happen that you are seeing a very long question, or you are seeing the variables out there. You may started feeling that what could be the answer. I can do this question according to multiple formats. I can show you the shortcut tricks as well. But here, first let's solve this in a genuine method. Using the genuine method, a particle of mass m moves on a straight line with a velocity increasing with distance according to the equation. So velocity is provided to us. The total work done by all the forces, the total work done by all the forces applied on the particle during its displacement from this to this. Now, we know what? Work energy theorem. If you apply the work energy theorem, you will get the answer easily. Work energy theorem says that work done is equals to delta of k, and velocity is provided to you as alpha root x. This is starting from 0 to this thing. So I can say that we'll get half mv square. V is alpha root x. Put half mv. Alpha square and d. You'll get instant answer. You'll get instant answer as there is another format according to which you could do. You could think of power. Wait, I'll get that connected. Power. There is another method. We know that acceleration, if we know that acceleration is equal to rate of change of velocity. Similarly, acceleration we could write in this format also. These are two acceleration formulas. Okay, you could use that formula as well. Now let's move. 2024 27th Jan shift 1, this question was being asked. According to this question, you have to find out the ratio of magnitudes of linear momentum. And I always wanted you to please remember this formula, because if you see the recent previous year questions, at least 5 years previous year questions, you will see that these types of questions are coming again and again. Even in modern physics, we'll be getting that we have to calculate multiple times the ratio of these momentum. Kinetic energy is equals to half mv square, and if I'll multiply m and m on numerator and denominator, I'll be getting p square divided by 2m. If I'll have to get the value of momentum only, I'll be getting 2m into kinetic energy. So this is basically my momentum in terms of the kinetic energy. According to this question, these bodies are having equal kinetic energy, and if I have to calculate the ratio pi by pf, I can do one thing. This 2 is constant, k is constant. I could write this thing as m1 m2, right? So you can replace this thing with root 4, root 25, 2 by 5. So 2 by 5 is my answer. Please remember this thing. Is this thing clear? My dear, please do let me know in the chat. Have a Josh. How's the Josh? How's the Josh? I hope that these things are clear to you. Your focus must be on getting the correct answer. Your focus must be not on the question, but on the concept which we are applying now. So this is the concept which is being repeated again and again. And if you got the same concept in your JEE 2025, you have to do that question within few seconds. Remember these things. Now, JEE 2024, 29th Jan shift 1. Here we have been provided a potential energy in terms of this function. What we have to do is a partial differentiation 2z. So you have been provided a potential energy formula here. An equation is there. The magnitude of x component of force we have to find out. So force of x will be equals to, tell you x. First you need to differentiate 4x and put as the point given to you as 1, 2, 3. This is x, this is y, this is z. Put x is equals to 1. Fx is equals to 4. Fx is equals to 4 Newton. What I am repeating again and again, that questions are not important for you. What is important for you is the pattern. There is a secret to get success. There is a secret to get success in JEE exam. I'm reiterating it here. What is the secret? What is the secret? The first secret is that questions are not important for us. What is important for us? That whenever you are solving any question, look for pattern. Look for pattern. There is my RUC strategy. Recognize the pattern of question. Recognize the topic. You recognize a pattern. Recognize the topic. Recognize the formula being asked in the question. At every time, whenever you are solving any question or you are reading any theory part, you have to recognize that which type of pattern it is, which type of topic, which type of formula is being used. Now, use that formula so that multiple times, use that formula multiple times so that you will be familiar, with if this type of question is coming, then you have to do this thing, and you will be 100% sure that this is the steps through which you can get the answer. And then the next stage is you can create that if there is a variation out there in the exam, then what could be the variation? Like here in this question is basically asking you the x component. If this question is asking you the y component, you have to do differentiate this thing. If this question is asking you what is the z component, you have to differentiate this thing, and you have to put similarly the values of y and z as per the question, right? So this is basically the approach which you have to use. And the second thing, this is the foremost successful. I have applied this technique to multiple times to multiple students, and they have provided me the result. The second thing is about law of exposure. The more you expose, the more success you will get. More exposure is more exposure, or I could say exposure is proportional to success. Now it's not a kind of Urfi Javed exposure. It's a kind of exposure to what? More questions. Exposure to what? More PYQs. You know what? You're not able to solve questions. It's not that you are not intelligent, or it's not that uh, you have done something wrong. It's simply that you have not been exposed to those types of questions. You have not been taught those type of questions. It simply tells that thing. So remember this thing in your mind when you are not solving a type of question. If you got one puzzle type of question in physics and you are not able to solve, it's not that you are not intelligent. It's not that you won't be get selected. It simply says that you are not being exposed to that type of questions till yet, right? You have to change that story. Whatever you are telling to your mind must be that you, if you got the exposure, you will get the success. Simple. Now let's move towards the next question. 2024 29th Gen shift 2. In this question, they're asking us a bob of pendulum was released from a horizontal position. The length of the pendulum was given. If it dissipates 10% of its initial energy against the air resistance, the speed with which the bob arrives at the lowest point you have to calculate. Okay, let me do one thing. This is the length. Okay, at this point you can say that potential energy is equals to mgl. Can you? And this potential energy is being lost when this object is moving. At this point there will be a kinetic energy, and you have to find out the velocity at this point. So according to the question, we have been provided that 90% of mgl is equals to half mv square. Mass and mass will get cut. E and L 100. So it's 90 is equals to v square by 2. V is equals to under root 180. 36 into 5. And you will get 6 root 5 meter per second. Okay. I hope that this approach is clear. What will be the approach here? Approach is very, very simple. Approach is, if you do not have any plan, if you do not have any plan, just search extreme ends. If you do not have any plan, just search extreme ends. What is the extreme ends here? At the extreme points here, I'm only having the potential energy. There is no kinetic energy at all, because we have raised this pendulum to a particular horizontal position, and at this position we are not having the velocity, and when we are releasing this thing, due to the air resistance, we are losing the 10% of energy. So this was the total energy which were generated when I am raising this to a particular height. And what I did here is I was taking only the 90%, because 10% is lost. So if 10% is lost, only 90% is left here, and this energy is available at this point, because at this point I am only having the kinetic energy. So my extreme points will be this point and this point. So this is what I am doing, and this is what I am comparing, right? So if you do not have any plan, just search for the extreme ends. You can apply this approach in your life as well. Just imagine that if nothing happens, or if your JEE exams does not go well, then what is the worst thing what will you be doing? And if your JEE exam got pretty well, then what will be the thing what you will be doing, right? So, sir, what beard oil do you use? Ninja Streamer. Do you think that I'm using the beard oil, and due to that beard oil, my beard is uh, having this size? No. It's just the genes. I'm not doing anything. I'm like most lethargic person, you could say. I'm a very lazy person. So it's that's why I have this kind of beard. This question is from JEE 2024, 38th Gen Shift 1. In this question also, you have to do similar approach, that if you do not have any plan, just go for the extreme ends. According to this question, a particle is placed at a point A of a frictionless track ABC as shown in the figure. It gently pushes right. There is a particular mass out there. And if I'll push this at this point, I could say that kinetic energy is 0. But there is potential energy, and that potential energy is mg. H is 1. At this point B, there is kinetic energy. We do not know about the kinetic energy, because we have to find out. So I could write this as half m VB square. There is a potential energy at this point that will be equals to half m, not half m, it's mg h by 2, 0.5. You could write this as mg by 2, right? And we know one thing, that total energy at this point and total energy at this point will be equals, right? So total energy at A will be equals to at total energy of B. Mg is equals to m will cut. G by 2 is equals to VB square by 2. This will cut. You will be getting VB is equals to under root G, and VB is equals to under root 10. Now, I am a kind of a teacher who always look for that what is the source from which the JEE is making the paper. And this question is basically directly from HC Verma. They haven't changed the numbers also. They haven't changed the numbers. If you remember this answer, that this answer is root 10, you could easily get. 10% is for confusion, right? Ninja Streamer, is it correct? Sai Tharun, Nirmal Ram, Ninja, and do share this session with your friends. Guys, this is very, very important, because we all want your support. If support is there, we will give you the best I could do. Now here, 2024, JEE 2024, 31st Jan Shift 1, it was a question. According to the question, the artillery pieces of mass M1 fires a shell of mass M2 horizontally instantly after the firing, the ratio of kinetic energy of the artillery to the that of the shell, they are asking you. Okay, then what will be your approach? How to get the answer? An artillery piece of mass m1 fires a subshell of mass m2 horizontally instantly after the firing. The ratio of the kinetic energy of the artillery and that of the kinetic energy of the artillery that of kinetic energy of shell. Okay, that is the question. You know what? We got that momentum is same in this case. Whenever we are having situation is momentum is same. Momentum is conserved in this scenario. And when the momentum is conserved, we know that P square divided by 2m is equals to kinetic energy. I can say that kinetic energy is proportional to 1 by m. And here you could write that artillery mass is m1 and this mass is m2. Easily I can mark this answer. Right? Let's move forward. Now, 2024, 31st Jan shift 2. The question was a force is being provided to us in a vector format. The power developed in the question they are asking. Mass is given to us. Now, we have already done this type of question. Why I always tell you that in this last minute revision, you have to solve previous year question. And your approach must be to get the concept right, to get the steps right, that these are the steps which you have to use. And we have already done similar type of question in this session only. Force is being provided to you, power they are asking, and we know that power is equals to force into velocity, right? I hope that this thing is clear to you. Now, accordingly, we do not have the velocity here. Velocity is not being provided, and to get the velocity, what you will do is according acceleration, like for getting the velocity, what I will do is we are being provided with the force. We know that force is equals to mass into acceleration. Acceleration will be equals to force by mass. So I'll get 3t I cap plus 3t square j cap. This is the acceleration which I'll get. Okay. This is the acceleration which I'll get. And if this is the acceleration, acceleration will give me dv by dt. And this v will be equals to the integration of 3t I cap plus 3t square j cap and dot dt. So this velocity will be 3t square by 2 t cube. So power is equals to 6t I cap, 6t square j cap. Velocity is 3 by 2 t square I cap plus t cube j cap. You have to multiply this and this, this and this. Power is equals to, please solve 9, 9t cube plus 6, 5. What? So I'll get this as my answer. And I already told you that generally in the recent years, NTA repeats its questions again and again. You have to be very familiar with the types of questions being asked in the complete session. I would say January session, April session, and in this session I'm covering the 2 years. I'm covering 2 years, 2023 and 2024. You have to sit and solve 3 years at least questions on your own. Then only you can say that work, energy, power is chapter is done. We have done similar type of questions here. I'll show you where it was. We have we have attempted this question earlier as well. Where it was, yes. This is the same question. That question was in, I think, numerical pattern. Right? If you know. Yes. This question. This question was from JEE 2023, 24th Gen, second shift. See, look at the question. You have been provided by the force. You have been provided by the time. You have to calculate the power here. And how you got the power? Power is equals to basically force dot V. Right? And similarly, we got the value of V here and we got the answer. Similar type of question. This was from January 2023. January 2023 attempt. Similar question you are getting in 2024 January attempt. I hope that this pattern is clear to you. Right, next. Let's move. This question is from JEE 2024. Now attempt this question on your own. I'm giving you a timer for this attempt. Let me start the timer. One minute timer is enough. Solve this question. Option C. Sir, when you will take system of particles and rotational motion, because it's very, very important, or will you come to watch it live? Because this is, I'll be taking that chapter next. I think Tuesday I'll be taking that class. Yes, Tuesday. Tuesday I'll be taking the system of particles and rotational motion. Now tell me, what is the answer? Nirmal Rana, what you got? Did you get the correct? This question is very, very simple. This question was asked in JEE 2024, 4th of April, shift 1. If a rubber ball falls from a height and rebounds up to the height, basically, there is some typing mistake, from a height h, and it rebounds to a height of h by 2. The percentage loss of total energy of the initial system, as well as the velocity of the ball before it strikes the ground. Okay, when the object is falling from a height h, the velocity at this point is equals to under root 2gh. I hope that you know this. How we could get this? Just by simply using the equation of motion, v square minus u square is equals to 2as. As we know that initial velocity is 0, v is equals to under root 2as, and we know that acceleration is due to gravity. So I could put this thing as acceleration due to gravity as g and the displacement as s. So I'll be getting to under root 2gh, right? And they are asking that how much velocity is being lost. So 50% is lost. So my answer will be first thing. I hope that this question is clear to you, because this object is going up to a height h by 2. And if it is going up to a height h by 2, then it must have lost 50% of its energy. Now let's move. This question 2024, JEE 2024, 5th April, shift 2. This question is very, very important. And I would say that this question is basically one of the question which I generally discuss in my class. But I have taken this in a question format this time. A body is moving unidirectionally under the influence of constant power. So power is being provided to us, that power is constant. So I could say that P is equals to Fv, and power is constant here. And you know what? That force dot, you can consider this thing as power as force into mass into acceleration, dv by dt v, and this value as constant, right? So I could write this thing. Mass is also constant. A body is moving, that means mass is also constant. So I can write this as v dv is equals to, I'll write a dot dt. A is constant. So v square, if I integrate this thing, v square by 2 is equals to t, right? We have to find out the displacement. So you can get and v is equals to constant under root t. And again, see, again, if I'll write that v is equals to, or I could write v is proportional to root t, dx by dt, which is my displacement, is proportional to root t. For x, for getting the x, you have to integrate this integration of root t dot dt. You have to increase the power, and power will be increased towards 3 by 2. I hope that pattern is clear to you. Is this thing clear, my dear? Array, is this thing clear? Nirmal Ram, I hope that this thing is clear to you. Let's move towards the next thing. Okay. JEE 2024, 5th April, shift 2. This question was being asked. A bullet of mass, this thing, is fired with a speed of 100 meter per second on a plywood, emerges with this much velocity. Okay. What I do is, in this format, you can easily get, there is a traditional approach. If you go by the traditional approach, you have to do one thing. The percentage loss will be equals to the change in kinetic energy final minus kinetic energy initial, divided by kinetic energy initial into 100. So that will give you the percentage loss, that how much percentage is lost. And by a shortcut method, what I am going to do is, there is an initial condition, there is a final condition. There is an initial condition, there is an final condition, right? So for the initial condition, u is equals to 100 meter per second. Finally, I'm saying that it's 40 meter per second. I'm not concerned about that what is happening here, what are the values. I'm mainly concerned about that how much percentage change is here. So to get the percentage change, basically I can take 5. So I could take that this value is going from 5 to 2. So P 2 by 5 to 100. So 40%. Basically we have like this value is basically the 40%, right? Final velocity is the 40% of this thing. And if I'm having an initial value, if this is the 40%, I could say that percentage loss in the kinetic energy will be equals to 16.16, 84%. So my answer will be 84% here. Now see the approach. What is the approach here? Our approach is, if the formula is basically proportional to the v square, then if my initial value is x and I'm increasing it by 10%, if I'm increasing this by 10%, I could write this as 1.1x. Okay, if I'm decreasing this by 10%, I could write this as 0.9x. How many of you are getting? And what I am telling you, that if this is a quantity A, or I could say if a quantity which you have to calculate is proportional to the square of something, then you have to do the square of this thing. If I'll do the square of this thing, then what will happen? It will give me 1.21x. It will give me 0.81. Right? So similarly, you could easily get that how much is the change. So for here, there is a change of 21%. And for here, the change from here to here is 19%. Are you getting my point? So similarly, if I'm getting this 40%, I could say that if I'll be taking it as 0.4, 16% I'm getting, and they're asking me the loss. So loss will be 84%. So this is the shortcut trick which you could use. Traditionally, you could simply get this by this. Okay. Yeah. Home one. Correct. Now let's move. Okay. Now we comes to the very, very important part. As I told you that there are some situations which we have to cover in this lecture series. So this was the topic. I'll show you that this was the syllabus, official syllabus of JEE 2025. So we have done that how we are going to find out the work done by a constant force, right? We have already done this. It work done according to the constant force is F dot S, and you could write this as Fs cos theta. For a variable force, it's F dot dx, or you could get an area under curve. area under curve is equals to work. We have done the kinetic energy and potential energy, we have completed, right? We have completed the kinetic energy and potential energy, work energy theorem we have completed, power we have completed, we have done similar types of questions, important types of questions which was there in JEE 2023 and 2025. Potential energy of a spring, okay, the potential energy of a spring is basically half k x square. The potential energy of a spring is half k x square. Conservation of mechanical energy, basically this is the approach which we were using when we have done two previous year questions, that you have to use the extreme ends. If you do not have any plan, search for the extreme ends. For the conservative forces, we do not take the path is not important for us, but for the non-conservative forces, path is important. Conservative forces are gravitational force, magnetic force, electrostatic force. These are the forces which is conservative. Or you could say that in conservative forces, we consider the potential energy. We do not consider the potential energy in the scenario of non-conservative forces. Now, the very, very important topic, the last topic, is the motion in a vertical circle. In a motion in a vertical circle. And this topic is very, very important, because you will see multiple questions being asked from this topic only. Now, what do you mean by a vertical circle? In a vertical circle, I could say that basically we are rotating an object in a vertical format like this. If I'll take one thing, let me assume that I am having a ball, and if I'll attach this ball with a string and I'll rotate this, right? So this will be my vertical rotation, right? There are two scenarios in this vertical motion. I could use a rod, or I could use a string. Or I could use a string. The question or the formulas will be different for both of them, right? So there might be a string or a rope. A massless rope will be considering, or there will be a rod of some mass. If I'm having a mass of m here and I'm rotating this object in this direction, right? So there are some scenarios which could get being changed. So first I'll discuss the condition for this rope, and then I'll move towards the road. My main concern is to take the, putting this thing here. Okay, this is case 1. This is case 2. So what I'm telling you is I'm considering a rope here or a string. Case 1 of rope or string. So I'm having a mass m, the length L. I'm rotating this object. Object will move at this point. Object will move this point. This all object will move to this point, right? So basically for me currently the important points are this one I'll write this point as A, this point as B, this point as C. And at all these points, they are being, like here also there will be this and this. Let me write the statements or some, which basically I have to equate the energies. I have to equate some similar scenarios through which I could get my derivations. I'm not very much interested in the derivations when I'm teaching for the JEE exams, but this specific derivation is very, very important, because when we do this kind of derivation, you'll get to know that how basically we are approaching this type of question, right? So let me write first thing first. If I have to write the energies, first what you need to do is you have to reach at these points A, B and C and write down the energies out there, that what is the energy at A, what is the energy at B and what is the energy at C. So I'm writing at point A. Energy at A is equals to half m. The velocity here is VA. Velocity here is VB. Velocity here is VC. So it's mVA square. At point A, the energy is half mVA square. Now, if you are at point B, the energy at B, now at this point, the energy will be due to the velocity. So due to the velocity, I'm having the half mv square. But also, if this object is being raised by a distance of L, this is also having a potential energy, and that potential energy will be equals to mg, and the distance by which it being raised from the ground, which I'm taking as a reference, is L. So I'll be taking the potential energy. I'm also considering the potential energy here. That's why I'm writing the mgl. What is mgl? Mgh is the potential energy, right? Now, at the very next moment at point C, I'm not taking this thing with me. At point C, 4 point C, energy at C will be equals to half mvc square plus, you know what, from there the reference value to here, we know that this L and L will get add up, then you will be getting 2m L. Are you getting my point? Are you getting my point? So this is what we are getting, right? And we know that all these energies are basically equal, because total energies are same according to law of conservation of energy. According to law of conservation of energy, EA is equals to EB is equals to EC. EA is equals to EB is equals to EC. All of these energies are equal. I hope that this thing is clear to you. Now, you know what we have to do is, what could be our next step? What could be our next step? Tell me. Our next step is, if I'll reach at point C, there is a critical condition. If I'll reach at point C, if I have to ignore the tension, then I know that due to this velocity only, basically I'm getting the centripetal acceleration. So what I am doing is, at point C, mvc square, mv square divided by L is equals to mv square by L. This is the centripetal force towards the center. will be equals to mg. And from here you can cut this. You will get Vc as root gl. And once you get Vc, that is the velocity at the C point. Why? Because at this point tension is 0. And once you get the tension at this point as 0, you can easily get like if I'll replace this value here, so using equation 3 EC will be equals to half m GL plus 2 mgl 5 mgl by 2. Okay, and this is fourth. Okay, using equation 1 and fourth, I'll get half mva square is equals to 5 by 2 mgl. M and m will cut, 2 and 2 will cut. Va will be 5 this is what we will get. Similarly, if I'll use the equation this fourth and second, okay, using equation fourth and second, I'll do this here. Using equation second and fourth, we get VB is equals to under root 3gl. This is very, very important. This is very, very important. It's how we could get the answer. So VA is equals to root 5gl if it is getting the complete round. This is root 3gl and this is root gl. The ratio is 5 is to 3 is to 1. Okay. I hope that this is clear to you. Is this thing clear? Is this thing clear, my dear? I hope that this thing is clear. Please do let me know. Please do let me know. Okay. Shall we move? Shall we move? Okay. Now, here is the question. This question is being asked, like this question is from NCRT. This question is from NCRT. According to this question, this example 5.7, this example is very, very important. According to this example, we have to obtain the velocity v naught. So v naught, we have already like got it as root 5gl. We have to calculate velocity at B. Velocity at B is root 3gl. Velocity at C is equals to root gl. So these are the velocity. Second, you have to find out the ratio of kinetic energy at B. you have to get the ratio of kinetic energy at B to the kinetic energy at C. Half m V square 3gl. So it's 3:1. Okay, so this is what we got in this question. I hope that this thing is clear. Please get this corrected. Home. Is this thing clear? Now let's move. Here, the question from JEE 2024, 29th Jan shift 2. There was a question, and if you know the concept, you could easily mark the correct answer. In this question, a bob of mass m is suspended by a light string of length L. It is imparted a minimum horizontal velocity at the lowest point A, such that it just completes half circle, reaching the topmost point B. So B is here. The ratio of kinetic energy to A and B they have asked. So kinetic energy at A means you know that velocity, light string is there. So velocity at this point is root 5 gl. Velocity at this point is root gl. And now you know that the answer will be 5:1. Kinetic energy at A is more than kinetic energy at B. Now you can also think in terms of that at A the kinetic energy will be more, at B kinetic energy will be less. So I know that numerator will be more as compared to the denominator. So if numerator is more as compared to the denominator, this won't be my answer, because in these answers my denominator is more. So these could not be my answer. My answer will be only these two things. Only A and B could be my answer. Now let's move towards the next point. This question is from H.C. Verma. Try to solve this question, because through this question you will be able to get the real approach which we could use. This question is from H.C. Verma. A figure shows that a light road, basically this question is from a light road. For a road type of question, I told you that we could have two types of question, in which one could be a rope or string of length L of mass m. And now here, the minimum velocity for complete circle will be equals to root 5 gl. Okay, and if similar question will be having a rod. So for rod, it's 4 gl. So for rod, it's 4 gl. And now let's solve this question. In this question, there is a light rod of length L. Attached to a small heavy block of mass m at one end and a hook at the other end. The system is released from rest from a particular height. Now there is a smooth ring at a depth of height h. So at a height h, I'm having a smooth ring here below the initial position of the hook, and the hook gets into the ring as it reaches there. What should be the minimum value of h so that the block moves in a complete circle about the ring, right? So we have to find out the minimum value of h, so that when it reaches here, it completes the complete round. Okay, now you can see there is a hook. The height h, the length l, the length l, mass. And we know that the minimum velocity here must be, for a complete round, will be root 4 gl, right? This must be root 4 gl. So you can do one thing here. The kinetic energy at this point will be equals to half m v square. V square is 4 gl, and at this point the potential energy is m g l plus h, right? Because at this point the real displacement is h plus l, and the potential energy at this point is mg h plus l. So I can equate these values. So I could write this thing as 2 mgl is equals to mgl plus mgh. M will get cut. I'll be getting gl is equals to gh. G and g will get cut. Then h is equals to l. This is what I'll get. I hope that this question is clear to you. Is this thing clear? Okay. Now I'm giving you the homework from H.C. Verma book. If you are having this book is must. You have only two homework. You have to do the questions from work, energy and power from this book, and the another homework is to only 64 questions are there. Okay, so your homework, first we will solve this. This is also, I'm giving you the homework. Velocity of the body at b, they are asking you a body of this much rest from a vertical circle from point A to B. Okay, so this question is also a homework for you. And other homework which I am giving you is solve H.C. Verma. Solve H.C. Verma complete. Second thing is solve PYQ 2017, 2018 and 2020. Okay, 23 and 24 we have already done, and if you really want to do practice, then you can go for that also, 23 and 24. We have already done this, but if you really want to do practice, then you can go and solve unsolved, like go for the unsolved. Sir, can I use? You can use that, but I would suggest to go for the H.C. Verma book, because from this book I have shown you that in the recent years you will be getting the exact question from there. Even in coaching module, you will be getting the questions from H.C. Verma. So it's better that to solve this book, because in this book you will be only having 64 questions. So solving 64 questions is easy as compared to solving 150 or 250 or 400 questions, right? So it's easy to solve this H.C. Verma. Okay. Even if you are not able to solve all the question, I would suggest that at least solve half of the H.C. Verma. And if you got any doubt while solving the H.C. Verma book, you could get let me know and in the chat or in the comment section. Okay, if you have any doubt, I'll take a separate session for that to discuss the HC Verma questions, and there are some videos of mine only to that in which I have discussed the HC Verma questions. So I'll take that further. Now, next class will be of rotational motion, so do not miss that class. I'll be taking that class on Tuesday. And do not forget to join our Telegram group, because on our Telegram group only you will be getting this PDF. Okay, so that is very, very important and required. Okay, so let's finish this lecture here. Till then, bye bye, and do share this session with your friend. Do join our Telegram channel. Bye bye. Best of luck.